We are delighted today to have as our speaker Dr. Shane Grosser from Merck at Merck CBDC at Rahway, New Jersey.
If I'm doing, instead of constant pressure, constant temperature, I'm going to say I want my batch to never exceed 45 degrees. So type that in. Type things like the jacket and temperature delta T. So say I want to really kind of push this a little bit harder from a distillation perspective. I'm going to set the jacket and batch delta T. If you have product, molecular weight, etc., or the molecular weight of the product, etc. Again, so that's how you basically fill out this first input dialog box. If once you've done that, then you go through and select, okay, well, this particular process uses isopropyl acetates. Instead of PHF, I'm going to use toluene, for example. I'm going to keep product. That's how you would define the components. You can select more components if you wanted. If you didn't, you would just kind of leave it blank, if you will. You're doing this solvent switch until you either A, run out of material in your feed tank, or B, you've actually met your target specification. So for example, this particular distillation would run until the isopropyl acetate weight percent level is less than 1%. So that's a snapshot of how you would go about filling out the input tab. To give an example, I'm not actually going to go through the simulation. It'll take a little while to parse because of the Adobe Connect. But at this point, the user is able to just kind of hit the Run in Simulator button. That pulls it into the DynoChem environment, and you're ready to execute a simulation. So it's really straightforward to kind of get to the point from, opening up the tool, inputting all the information that you need, and then running a distillation. I guess the question is now, well, so what, right? So why is that helpful? Why do we see the value in going through the trouble of developing a front end for that? A couple different things, right? I think the main thing is, from a so what perspective, is start to finish, provided you know the composition of your material and the target you're trying to get to and the vessel you plan to operate in, you can have a model soup to nuts built in less than 10 minutes. You can be simulated and reported out your results within that 10 minutes. It's pretty straightforward. Talk a little bit about accuracy of this particular model, because that's one of the things that we actually really like to stress, is that it's important when you're actually doing a modeling activity to not only understand how to use the model, but to also understand what assumptions are inherent in the model, as well as what level of accuracy you should expect out of the model. So I'll give that for this particular model. And again, that's information that's kind of captured on the wiki page. It all talks about what errors or what assumptions are inherent, what accuracy you should expect. But for this particular model, I would say that provided you know your initial composition quite well, the final composition profile that predicted by this tool is consistently very accurate, right? All right, so that's kind of an accuracy, from an accuracy perspective. I think more importantly, I want to talk about adoption. So the distillation tool was one of the first tools that we had a front end for. It's very flexible. It can handle just about every type of distillation that we would typically conduct in the pilot plants here in Rahway, as well as many of the other supply sites across Merck's network. I would say that almost all distillations that take place in the Rahway pilot plants are undergoing a simulation prior to batch execution. It is straightforward enough that there really is no excuse not to do a distillation prior to running in a pilot plant here. So I would say distillation model, probably almost total adoption into our workflow, or our process development workflow. We have over 200 log, this is as of December of last year, we have over 200 log users of DynoChem across Merck's network, right? So about 200 users that have used DynoChem at one point or another. I would say almost a vast majority of that is actually enabled through the use of customized front ends. The reason I say that is because out of 200 log users, less than 40 of those engineers have been formally trained in DynoChem, and maybe 15 to 20 of those are what I would consider truly proficient in model building. So you have hundreds of users that are using DynoChem without knowing how to use DynoChem, right? And I think that's really the benefit that we see with these front ends. One of the things that we found that this has led to is that, people say, hey, I used the distillation model last week. It was awesome. It solved the problem that I needed. It was great. I noticed that it used DynoChem, but I don't know anything about DynoChem. I just used it last week without knowing anything about it. What else can you tell me about DynoChem? Or is there training opportunities so that I can become more proficient in actually using DynoChem?